Welcome to this tutorial on creating random arrays with NumPy. Today, we'll explore the np.random.rand function, a powerful tool for generating arrays filled with random numbers from a uniform distribution. This function is essential for data simulation, testing algorithms, and initializing neural network weights. The np.random.rand function is a NumPy method that generates random floating point numbers from a uniform distribution. The key characteristic here is that all values fall between 0 and 1, and each value in this range has an equal probability of being selected. This is what we mean by uniform distribution. Let's look at the basic syntax. First, we import NumPy as np. Then we call the function using np.random.rand, followed by parentheses containing the dimensions. The parameters d0, d1, d2, and so on represent the dimensions of the array you want to create. You can specify as many dimensions as needed for your particular use case. The simplest use case is generating a single random number. When you call np.random.rand with no arguments, it returns a single floating point value between 0 and 1. In this example, we store the result in a variable called number and print it. The output shows a random decimal value like 0.5488. To create a one-dimensional array, pass a single integer as the argument. Here, we're generating an array with 5 elements by calling np.random.rand with the argument 5. The result is a one-dimensional NumPy array containing 5 random values, all between 0 and 1. Each value is independently generated from the uniform distribution. For two-dimensional arrays, pass 2 arguments representing rows and columns. In this example, we create a matrix with 3 rows and 4 columns by calling np.random.rand with arguments 3, 4. The output shows a two-dimensional array where each element is a random float between 0 and 1, arranged in a grid structure. You can extend this to 3 dimensions or higher. Here, we create a 3-dimensional array by passing 3 arguments, 2, 3, and 4. This generates a tensor with 2 blocks, each containing 3 rows and 4 columns. The shape attribute confirms the dimensions as 2 by 3 by 4. 3-dimensional arrays are commonly used in image processing and deep learning applications. Let's recap the key points. First, all generated values range from 0 up to, but not including 1. Second, the uniform distribution means every value in this range has equal probability of being selected. Third, dimensions are specified as separate arguments, not as a tuple. And finally, calling the function with no arguments returns a single floating point number. These fundamentals will help you effectively use np.random.rand in your data science projects.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.